Hello everyone, I'm Srinath. In this tutorial, I'll be showing you what you can do with the 4MD software and use it for the design project. And in this tutorial, I'll be discussing following points. The downloading of the software, building simple 4-bar mechanism, image import function, building mechanism with the help of image import, the slider count mechanism, and 3-position synthesis of a mechanism, and the last one is dimensioning. To download the software, you have to go to Blackboard. On the Blackboard, you have to select the Robot Design Project site. Here, there is a tab called Software for Linkage, Synthesis and Simulation. Once you go through it, here is a link for 4MDS software. You have to download it. Once you save it, you have to extract the zip folder. Once you download the software, this zip file, you have to extract it. You don't have to install it. You can just copy paste this into your flash drive and take it with you. You can use on the other computers without even installing it. Once you extract the folder, these are the files which you will see. Here is the application file. You have to click on that and the software will be running. Okay, this is the graphic user interface for the 4MDS software. Here there are many icons you can see. We'll go one by one. There is circle constraint. You have to select that. Let's create a 4-bar mechanism. Just click on any space here, then drag it and leave it. Here's the link where this is the fixed pivot and this is the floating pivot. To create 4-bar, you have to do this again. Leave it. Now this is the 4-bar mechanism. So here are the 4 links of 4-bar mechanism. One is ground link, this is second, this is third, and this is fourth. This link is called coupler link. This is a coupler. When you click on this icon, you can change it. You can change this triangle. By changing this triangle, you can see that there are different paths that are formed. You can animate this 4-bar mechanism by clicking on the play animation. As you can see, this is tracing the blue path. There are 2 paths for 4-bar mechanism, which are called 2 different topologies. These are nothing but the outcome of 2 different arrangements for the mechanism. To switch to red, you have to select the toggle branch, and here we go. It is 4-bar with the different arrangements of the links. These 2 arrangements have same lengths, but the arrangement is only which is different. So we have play it. Here we go. If you want to change the actuator from this joint to this, you can just change it. Swap input diode. Look, now this will be the driving motor and this will be the output shaft. This is the simple 4-bar mechanism. Now we will see how to import the image. So this is the 4MDS software. Now let's import this image. First you need to scale it, select it, enter it, then you can orient it. It doesn't matter actually. It's fine. Then let's build a 4-bar mechanism which is given in this photo. Clicking the circle constraint, click, drag, dropping. Again click, dragging, dropping, Now here is my coupler dragging. Now here we go. Now there are two independent topologies, as you can see here displayed. By default the blue is played. Now let's toggle the branch. Now let's see how it works. So this is D-shaped. So this mechanism is used for walking. If you reverse the actuator direction, now we will see slider mechanism. So this mechanism is used in IC engines. So let's build it. Let's import the image. Everything is good. Done. Then we need a pin joint from this fixed point to this crank, which will rotate like this. Now we need a piston. So piston is constrained to move in a straight line. So this is a fixed line constraint. So we'll use that. This is our coupler. Let's coincide with crank. Now look at this. Now we'll see the 3-position synthesis with the dimensioning altogether. So we'll clear it, we'll add the image. So suppose this is the, so this image is huge, I need to reduce it. So when you select it and enter it, the size will get reduced to scale 1. So now here, this is the dust pan, this is the trash bin. I need a mechanism which will collect the trash, then rotate it, flip it, and so that the trash will go inside the trash bin. And this is my outer structure of the truck. So what I'll have is, I'll have a 4-bar mechanism which have 2 fixed joints on this body of the truck. So I don't know what linkages I'll need to achieve such motion. So let's try it with the 3-position synthesis. So it asks me what are the pivot constraints. So let's say I want my pivots to be here. Let's shift them. Yeah. Now this will be my coupler, which has these 2 orientations. Sorry. So what I'll need is input a task position. So this will be my first task. So suppose this is the orientation for my first position, and this will be the last. So let's suppose it's upside down, and then let's say my dustpan is rotated in such fashion. Oh, what I got is 2 different topologies which satisfy 3 points, but there is a problem in it. What's the problem? Let's play it and then we'll find out. Oh, so this path goes to these 2 points, and there is another path, which will follow this orientation. but I need a mechanism such that a single topology should have all 3 points inside it. So what can I do? All I know is these two positions are something that I need. And just let's try with the different position. Let's see if I can get it. Let's see what I got. Let's see what I got. Okay. Okay. So let's check. Let's say this is my pan. This is my pan. Now it's horizontal. Now here you can see. So it's upside down. Now you can see that this is horizontal but upside down. That means when I collect the trash, it will remain inside until it's upside down, and then it will dump it. So I have found my solution. Now I need to dimension it. So let's see. Okay, so this is my solution. This is the 4-bar that I need. So what I'll do is view, show dimensions. Here we are with all the dimensions with the 4-bar that we need. So for different positions of pivots or different type of mechanisms, like this is all revolute, you may use prismatic joint here, and then you'll get different mechanisms. But main thing is that it should rotate this dustpan to its desired orientation. We are working on the PDF export function, but right now you just have to note these dimensions down on your sketchbook and then send us the design. We'll cut them. And one thing before you finalize your design is to check the forces. Check if reactions and the driving forces are in the within limit or not. For that, I'll recommend you to use the Autodesk Force Effect Motion, Autodesk Force Effect, to analyze the forces that are needed to make this mechanism work. Such as, to make this mechanism work, it needs some torque for this motor to rotate. So in order to know the torque or to calculate the torque, you will need to know simulate this mechanism. And Autodesk Force Effect Motion has a lot of such kind of functionalities. Autodesk Force Effect Motion has a lot of such kind of force effect. Autodesk Force Effect Motion has a lot of such functionalities which will enable you to find out the reaction moments and the forces. That's it for today. Thank you for watching. Have a great day.